All right, so practice test, this includes the concept byte. Concept byte through 6-3. And the concept byte we see in the first few problems here. So this says simplify each expression and use only positive exponents in your final answer. We talked about this when we did the concept byte. You should still try and follow the order of operations. It usually makes things easier. So the first thing we'd look at for number 1 would be what's in the parentheses. Is there something that can be simplified inside the parentheses? There sure is. What is it? We've got a negative exponent, and it said right here, use only positive exponents in your final answer. So let's go ahead and make this 3x to the third over y to the fourth cubed times x to the sixth, y to the 12th. Usually when people make mistakes on these, it's because of the negative exponents. So it's good to try to get that stuff out of the way. Any more simplifying we can do inside the parentheses. So now we have to raise it to the third power as long as there's no addition or subtraction in there. Is there any addition or subtraction in our parentheses? Cool. So that means we can distribute the 3. That'll be 3 to the third, but variables work different. What do I get when I raise x to the third power? 9th. We have to multiply those powers. So it's y to the fourth cubed. Y to the 12th. Now I realize I have a fraction, and I'm going to make the second one a fraction because when you work with fractions, it's easier to have everything be fractions. And now at this point, one of the things we said we should do was make it look like math we had already done before. And the math we had done before involved just having one fraction. So we would put these together into one fraction, and that would give us, what is 3 to the third? Third. 27. X to the, when you multiply similar bases, what do you do to their exponents? Add them. So it looks like there's one more thing we can do in this problem, right? Yeah, these are gone. You can think of it like canceling. And we get 27x to the 15th. You're looking at 2 and saying that's a whole lot of gunk. So organize it. Think, if I can make it into one fraction like this one, then I'll be fine. There's a lot of negatives and stuff going on, so let's just do the division. 21 and 14, what do they have in common? So let's go ahead and reduce those. And then let's divide. When you divide similar bases, what do you do with the exponents? You do subtract. Negative 4 minus 1 will be a to the negative 5. B squared, b to the fourth, 2 minus 4 is negative 2, but then be careful with the last one. C to the 3 minus a negative 2, what would that be? C to the fifth. Now we're more organized so we know which ones will stay on the top and which ones will go down below. Which of those variables gets to stay on the top with the 3? Right, c to the fifth, because that's positive. The other two have to go down below so they can become positive. Anything else left for us to simplify in there? So that one's done. Oh, I didn't write the 2 down. I had it there and I didn't write it. Thank you. No more negative exponents. It's ready to go. Take a look at number 3. Inside the parentheses first, what should we do? Yep, let's move it. So So that was one little bit of flipping we had to do. Are we done flipping? Nope. Now the whole thing has to be flipped. So we can get rid of the negative on the outside of the parentheses. Now what do I need to do with that 2? Distribute. What does that mean? What are we going to do with m to the 3rd and a 2? We do multiply. When you raise a power to a power, you multiply. So last but not least, we need to figure out what 4 squared is. It is, 16. And 3 squared? There it is. I'm not going to scroll way back up to put it on the line, but anything else we could simplify with that. Okay, so that's good to go. So those were some good concept byte problems. I mean, that's what we did when we spent a couple of days on that concept byte. All of those types of problems. Anybody need more time? Because I see some people writing like crazy. When we do the practice test in class, never a good idea to get too far ahead, and then what happens is you do something wrong, and you look up and we're already off to the next problem, and you don't know you've done it wrong, and you practice it wrong, and then you do it wrong on the test. So try to stick with this. Find all the real square roots of each number. Square root of 196. Okay, did I write the square root symbol? So then it's not just 14, what is it? Plus and minus 14. Square root of negative 121. No? Why not? It'd be imaginary, wouldn't it? No real solutions. Cube roots. Cube root of negative 729. And we were thinking of this as slots when we did these before. So use your power chart. What you got? Negative 9 it is. Cubed root of 512 216ths. Yuck. Wouldn't want to think of it that way, right? Let's split it up. Cubed root of 512. 8. Okay, cubed root of 216. But wait a second. We could reduce that. What's that reduced to? We've got it. Now what that means is it was probably reducible when we started too. We probably could have reduced the 512. Well, okay, we absolutely could have reduced 512 over 216 and then done the problem as well. So either way. All right, so far so good. Concept byte, little square root action, little cube root action. Now we start the hard work. Simplify each radical expression. Ooh, we better underline this. Use absolute value bars when needed. Remind me again, when do we use them? Even roots with odd power answers. Okay. Well, in number 6, we have to remember that numbers behave differently than variables. So we separate those out. Do we know the square root of 144? 12. And then we'd separate these into our little x squared, square roots of x squared, and square roots of y squared. And we know that this would be x, x, and x, y, 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 and y. So when it's all prettied up, it's 12 what? X to the third, y to the fourth. Unless it needs absolute value bars. Does it? It does, doesn't it? For that little bugger right there. 12 absolute value of x to the third, y to the fourth. Okay, that kind of went all over the place, so maybe I'll have to fit 7 down here. Cubed root of negative 216, cubed root of a to the third, cubed root of a to the third, cubed root of a to the third, cubed root of a to the third. Why did I have to write so many cubed roots of a to the third? I had to have 12 total. Because up there it's a to the 12th. Cubed root of negative 216, is that something on your power chart? Negative 6. How many a's are we going to have over there? 4 of them. Negative 6, a to the fourth. Fourth root of 3,125. Fourth root of, I might as well split some of my variables right now. Fourth root of x to the fourth, fourth root of x to the third. We're not going to have a perfect one there this time. Fourth root of y to the fourth, fourth root of y to the fourth, fourth root of y to the fourth, and then one leftover y value. All right, 3125. Fourth root of 3125, that doesn't show up on the power chart, does it? Fourth root 3125, no, it's not there. But one of them, and a pretty big one, divides into 3125. What is it? 625. How many times? So fourth root of 625, fourth root of 5. We've got an x, a fourth root of x to the third, a y, a y, a y, and a fourth root of y. Yikes! What is the fourth root of 625? Okay, so we're going to have a nice 5, then we're going to have an x, we're going to have a y to the third, and then we're going to have some uglies. Fourth root of 5, x to the third, y. And we might not be done. Does this require absolute value bars? One variable, both variables? Both, the x and the y to the third. Not the stuff under the radicals. We don't put absolute value bars on those. Just the answers that are out in front. Now we've got it. That might have been like the toughest one so far. Let's go down to 9. Cubed root of 125, cubed root of a cubed. Got to write that one a few times. And then we've got a cubed root of b. Huh. So a lot of a's, not so much with the b's. Cubed root of 125, is that something nice? Jameson? If you're using division, no. But remember, if you make a mistake, the problem is, where am I going to find it? You know, but be careful and then you'll be all right. Alrighty, so cubed root of 125 is? Power charts, folks. 5. What's the cubed root of a to the third? 1, 2, 3, 4 of those, and then a nasty little cubed root of b sitting there by itself. So what's the pretty part of this one? 5a to the fourth, and then we've got our ugly little cubed root of b sitting right there. Does this one need absolute value bars? No, this was a odd root because we had a little cube root going there. All right, let me write number 10 down here so I have some space. Alrighty, so we've got square root of 98, square root of s squared, square root of s squared, square root of s squared, square root of t 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 squared. 98, is that a perfect square? How about any nice perfect squares that go into it? How many times? Yep, how many times? Twice. S, 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 T, 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 T. Square root of 49 is? So we get 7s to the third, t to the fourth, square roots of 2. Absolute value bars? Where? Right there. Cubed root of 432. I don't think that one shows up on our power chart. So at least I was able to separate my y's. Cubed root of y to the third, cubed root of y to the third, cubed root of y to the first. Cubed root of 432. On your power chart. 432 would be here. 343 is not going to go in. Wait a second. 216. How many times does that go in 432? Twice. So what is the cubed root of 216? Power chart, cubed root of 216 is 6. Unless anybody thinks we need some absolute value bars. Need any? Cube root doesn't need them, right? Okay. So those are pretty tough ones. Let's finish up with 12. Fifth root, oh my goodness golly. Negative 729. Ooh. I heard some clicking calculators, so did somebody find it already? Fifth root that'll go into negative 729. Caitlin, you got it? It is. And let's make it a negative 243. So we can take the negative out. That goes in 3 times. And then we've got an x and an x. Fifth root of x to the first, a y, and a fifth root of y to the third. Whew. And what is the fifth root of negative 243? Negative 3. All right, let's pull it all together. What's the pretty part of this one? What would go in front? Negative 3, x squared, anything else that's pretty? 1y, and then we do the uglies. And we might be done, but maybe not. Does this need absolute value bars? Odd root. That's done. Now, if you're thinking 6 through 12, those are kind of tough. Yeah, they were kind of tough when we did them too. You know, there's a lot to work with there. Tomorrow's will seem a little easier because it's going to be fresher in your mind. Now, I have one review assignment for you for both days. It covers both days, and it's a little packet, so I'll get that for you. You want to try and do about half of it tonight, and then save about half of it for